In part 1 of this video, we find transformer ratio or turns ratio, and it was epsilon 2 upon epsilon 1 equals output EMF upon input EMF, that is equal to N2 upon N1, where 1 is for primary coil and 2 is for secondary coil. While finding transformer ratio, we consider three assumptions there that we have to keep in mind कि हमने क्या क्या assume किया था and under what assumptions transformer ratio comes out to be this. So these assumptions that we have taken are, first is स्टार्टिंग में हमने कंसीडर किया था दैट द terminal of the secondary coil is open, means there is no load connected to the secondary coil. So the very first assumption that we consider in the start of this derivation of transformer ratio was the terminals of the secondary coil are open. I'm writing it S. Secondary coil was S. So terminals of S are open. That was our first assumption. After that, second, we assume that there is no leakage of flux, means same flux link with both primary and secondary windings, and we consider that there is no flux leakage or that leakage from the core is negligibly small. So what we consider that there is no flux leakage or flux leakage from core is negligible. Right, and इसका हमें result ये मिला था that flux connected with both primary and secondary coil was same. So flux connected with P is equal to flux connected with secondary coil. This is actually the flux that is connected to each turn of the coil, means flux connected to each turn of the primary coil is equal to flux connected to the each turn of secondary coil. This was our second assumption, and the third assumption was the primary resistance of that inductor was small. That's why we neglect the term Ri1 in the derivation. So we consider that the primary resistance and the current are small. So these are the three assumptions that we made while finding the transformer ratio. Now for once we find the transformer ratio, now there come two possible cases. First, give us a step up transformer, second give us a step down transformer. So हम दोनों के बारे में बात करेंगे, step up and step down. Now we know that in a step up transformer, number of turns in secondary coil is more than number of turns in primary coil. Since N2 is greater than N1, so that's why the ratio N2 upon N1 is greater than 1. So the ratio of number of turns in secondary coil to that of primary coil is greater than 1. This shows that the transformer ratio is greater than 1, or we can say that epsilon 2 upon epsilon 1 is also greater than 1, which implies epsilon 2 is greater than epsilon 1. And this shows that epsilon 1 is the input EMF, epsilon 2 is output EMF. This shows that output voltage is greater than input voltage in case of a step up transformer output voltage is greater than input voltage. So this is for step up. Now similar thing for step down. In step down we know that N2 is less than N1. Number of turns in secondary coil कम होते हैं in comparison to the primary coil, which implies that N2 upon N1 का ratio, N2 and N1 का ratio, that is N2 upon N1 is also less than 1, or this is the transformer ratio which is less than 1. This shows that N2 upon N1 less than 1 होगा तो epsilon 2 upon epsilon 1 भी less than 1 होगा, which implies epsilon 2 is less than epsilon 1, and this means that output voltage is less than input voltage. Hence, when we use step up transformer we get increased voltage, and when we use step down transformer we get reduced voltage. So we use it according to our need, whether we want to increase the voltage or we want to decrease the voltage of the alternating current. So here we talk about the number of turns and voltage. Now let's try to connect current in primary and secondary coil with this relation. So we assume that we are considering that I1 and I2 be the currents in primary and secondary coil. Then if the transformer that we are using is ideal, if the transformer is ideal, now ideal means that no energy loss is present. Okay, ideal means there is no energy loss. We assume that I1 and I2 are the currents in primary and secondary coil respectively, and the transformer that we are using is ideal, that means there is no energy loss. Then in such case input power is equal to output power. Since there is no loss, so input power must be equal to output power, or we know the formula of power is voltage into current. So it is epsilon 1 I1, that is input power, is equal to epsilon 2 I2. On rearranging this we get epsilon 1 upon epsilon 2 is equal to I2 upon I1. So ट्रांसफॉर्मर रेशियो की अगर हम बात करें, ट्रांसफॉर्मर रेशियो वाज epsilon 2 upon epsilon 1, that is output upon input EMF, is equal to था N2 upon N1 के, that is number of turn in secondary coil to that of number of turn in primary coil. It will be equal to epsilon 2 upon 1. Now 2 upon 1 is 1 upon 2 in terms of current. Epsilon 2 upon epsilon 1 is I1 upon I2. So this will be equal to I1 upon I2 in terms of current. Hence, a step up transformer that is stepping up the voltage, it will step down the current exactly in the same ratio. If it is increasing the voltage, it will decrease the current, and if it is decreasing the voltage, then it will increase the current. Now this was the ideal case. For ideal transformer, efficiency will be 100%, and formula for efficiency is power output upon power input into 100, and the answer will be in percent. So this is the percentage efficiency formula for transformer. For an ideal transformer, if we consider an ideal transformer, then in that case this efficiency will be 100%. That means for an ideal transformer there is no energy loss. जितना इनपुट पावर उसने लिया उतना एग्जैक्टली हमें आउटपुट में कन्वर्ट करके दिया. दैट मीन्स इनपुट पावर इज इक्वल टू आउटपुट पावर, और द रेशियो ऑफ 2 इज 1, मीन्स इनपुट पावर इज इक्वल टू आउटपुट पावर, और इनका रेशियो 1 होगा. देन फॉर आइडियल ट्रांसफॉर्मर दिस ईटा इज इक्वल टू 100%. But the transformer that we are using in our real life, that means for real transformers, it is not exactly 100%, but it can go up to 99%. So for real transformer, eta can vary from 90 to 99% approx. We can consider that. मीन्स इतना एफिशिएंट हम बना सकते हैं रियल ट्रांसफार्मर को, बट एग्जैक्टली 100% हमको नहीं मिलेगा. सिंस एग्जैक्टली 100% नहीं मिल रहा है, देयर आर सम लॉसेस. दैट मीन्स दैट कि वो जो 1% डिफिशियंसी हुई पावर में और वो कंजम्पशन हुआ या लॉस हुआ, that 1% is because of some reason. That means there are some possibilities of energy losses. So now we are moving to the main causes of this energy loss in transformer. So first cause for energy loss in transformer is copper loss. Now what does it mean? Since the windings or the wire that we are using is of copper, so some energy is lost due to heating of copper wire. This is due to heating of copper wire that are used in primary and secondary coil, and this power loss can be minimized by using thick copper wires of low resistance. Since we know that resistance is inversely proportional to the area of cross section, so power is equal to I square R. If we reduce the power, if we reduce the resistance, power will reduce, and to reduce the resistance we have to increase the cross section area. Since R is equal to rho L upon A, that means if we increase the area, resistance will decrease and hence power will decrease. So basically we have to use thick wires to minimize these losses. Okay, this is the first kind of loss. Second is the eddy current losses. Now eddy current loss is due to the alternating magnetic flux which induce eddy current in the iron core, and to minimize this loss we use laminated core in the transformer. So these are due to alternating or changing magnetic flux because it produce eddy currents in iron core, and this can be minimized by using a laminated core in transformer. So we are going to use laminated core to reduce eddy current losses. Third is hysteresis loss. During this process, the alternating current in the core cause magnetization and demagnetization, and because of this magnetization and demagnetization, work is done in each cycle and there is loss of heat. So this loss is due to magnetization and demagnetization cycles. Because of these cycles there is some work done in each cycle and it is lost in the form of heat. This is called hysteresis loss, and to minimize this we have to use core material which has narrow hysteresis loop curve for it. So हमें ऐसा core material choose करना है जिसका hysteresis loop narrow होगा. Narrow hysteresis loop. Okay, this is the technique. Next is the flux leakage loss. In ideal case, we consider that the flux of primary is completely linked with the flux with the secondary coil, but actually when we are talking about the real transformer, it is not the 100% case. There may be some loss, although these loss can be minimized by winding primary and secondary coil over one another. Instead of keeping them apart, अगर हम उनको एक दूसरे के ऊपर ही wound करते हैं, in that case there will be the minimum flux leakage. So this flux leakage का मतलब है, this loss is because of the mismatch of flux, means flux in primary coil, that is P, is not equal to flux in secondary coil. Although we try to match it, but ideally ऐसा ज़रूरी नहीं है कि exactly equal हो. There may be some leakage of flux and it can be minimized by winding primary and secondary coil over one another. एक दूसरे के ऊपर overlap करते हुए हम उनको wound करेंगे. In that case the flux leakage will be minimum. Now the last factor that is responsible for losses is humming loss. This is called humming loss. So when transformer is working and there is alternating voltage present in the transformer, in that case the core change its size minutely, means थोड़ा like slightly उसके length में core के size में change आता है. It increases and decreases its size, very small change in size, means जैसे आपका अल्टरनेटिंग वोल्टेज में साइकिल्स होंगे, इन दैट सेम मैनर जो साइज होगा कोर का दैट विल चेंज स्लाइटली, बहुत माइन्यूट चेंज होगा. एंड दिस फिनोमिना इज कॉल्ड मैग्नेटोस्ट्रिक्शन. आई एम राइटिंग द फिनोमिना हेयर. दिस फिनोमिना इज कॉल्ड मैग्नेटोस्ट्रिक्शन. सो हमिंग लॉसेस are because of this magnetostriction, some humming sounds arise there, and because of these sounds there must be some electrical energy which is converting into sound energy. So some electric energy is lost in the form of that humming sound energy because of the phenomena of magnetostriction happening there in the transformer's core. So this loss is basically due to the sounds, in the form of sounds. When we have big transformers, हम practical transformers जब देखते हैं, we can hear some sound whenever we pass across them. So that humming sound, actually sound is a form of energy. That means there is some energy which is converting into sound energy and getting dissipated. So that loss is called humming loss. After these losses, we have to study the use of transformer. So first of all, transformers are used in communication purpose. Now in communication purpose, these are used in telephones, in radio receivers, in loudspeakers, etc. Second, transformers are used as voltage regulators in many equipments like television, refrigerators, ACs. ACs means air conditioners, computers, etc. So these can work as voltage regulator as well as voltage stabilizers. These are also used to stabilize power supply. This is also one of the use of transformers. Next is that the step down transformer is used for obtaining large current. Since a step down transformer gives us low voltage, that's why the current is large in that case. So a step down transformer is used in obtaining large current, first for electrical winding, and second it is used in induction furnace for melting metals. So there are two uses of step down transformer. These two uses are, first is for obtaining large current for electric windings, राइट. इलेक्ट्रिक वेल्डिंग जो हम करते हैं उसके लिए हमें स्टेप डाउन ट्रांसफार्मर की नीड आती है. एंड द सेकेंड इज इट इज़ यूज्ड इन induction furnace, basically because of the large current it produce heat in induction furnace for melting metals. And the last one is it is used in transmission of electric energy. Now this is very important. Transmission of electric energy from generating station to household or consumers. One more use of a step up transformer is it is used for production of X-rays. For production of X-rays. This is for step up only. This is for step up. Step down is not used for that. Step up is used for production of X-rays. ये इसमें इन सब में से जो ये fifth point है, this we have to study in detail a bit. Transmission of electric energy from generating station to household means आपने इलेक्ट्रिक स्टेशन पे इलेक्ट्रिक पावर प्लांट में इलेक्ट्रिसिटी जनरेट कर लिया, उसको आपको ट्रांसफ़र करके अपने घर तक लेकर आना है फॉर द यूज़, कंज्यूमर तक लाना है. तो वहाँ हमें ट्रांसफार्मर की नीड होती है बिकॉज ऑफ लॉन्ग डिस्टेंस ट्रांसमिशन. रीज़न इज़ दैट कि जो एनर्जी हम कंज्यूम करते हैं दैट इज़ लो वोल्टेज एनर्जी. सिमिलरली जो हमने प्रोड्यूस की दैट इज़ ऑल्सो लो वोल्टेज एनर्जी, बट this low voltage energy is not effective in terms of long distance transmission. There are certain disadvantages if we transmit electric power at low voltage. So these disadvantages are, first, if we have to transmit for a large distance, then the transmission cables must be large and these cables have certain resistance. So if a large amount of energy is passing through them to a large distance, there will be a loss of energy in the form of heat during the transmission. So first disadvantage is that you know that if we have large cables, right, if we have large cables then उनका अपना resistance होगा R, and because of this resistance I square RT, this much energy is lost in the form of heat during transmission. First thing. Second thing, जो voltage हमने send करा है, if it is low voltage and there is a long distance of transmission, then during transmission there is voltage drop along the wire, along that line wire. जो भी हमारा पूरा लाइन वायर है उसके अलॉन्ग वोल्टेज का ड्रॉप होगा, दैट विल बी इक्वल्स टू IR. ओके, सो इफ वी आर ट्रांसमिटिंग अ लो वोल्टेज पावर और उसमें से भी वोल्टेज ड्रॉप हो गया, सो इन दैट केस पावर that we are getting at the other end will be of very low voltage. So ये बहुत कम वोल्टेज की हो जाएगी. You are sending 220 volts और उसी में से ड्रॉप हो गया अक्रॉस द केबल, तो जब वो कंज्यूमर तक पहुंचेगा इट विल नॉट बी ऑफ यूज प्रॉपरली. दिस इज द सेकेंड मेन प्रॉब्लम. थर्ड रीजन इज दैट if the voltage is low, करंट शुड बी हाई बिकॉज पावर तो हमें कांस्टेंट ही रखना है. अगर वोल्टेज लो है तब करंट हाई होगा. एंड टू कैरी लार्ज करेंट्स एंड टू कीप द रेजिस्टेंस ऑफ ट्रांसमिशन वायर लो, थिक वायर हैव टू बी यूज्ड. एंड द कॉस्ट ऑफ इंस्टॉलिंग थिक वायर, कितना मोटा हम वायर करेंगे उसका कॉस्ट उतना ज़्यादा हाई हो जाएगा. दैट मीन्स in that case the process will be very costly. reason is that अगर हम लो वोल्टेज को डायरेक्ट ट्रांसमिट करेंगे फ्रॉम जनरेटिंग स्टेशन से, दैट मीन्स वी आर ट्रांसमिटिंग high values of current, and to carry such high values of current we have to reduce resistance, otherwise heating effect बहुत होगा. अगर I ज़्यादा है तो आपको R कम करना पड़ेगा. And to reduce resistance we have to increase area, means we have to use thick cables for that. And to use thick cables means first we have to form cable thick, in which there will be some additional cost, and then installing those thick cables is a costly process. So the cost of installing thick wire will be extremely high. So हम यहाँ पर इन सारे issues को cover करने के लिए, हटाने के लिए, ख़त्म करने के लिए, what we do, we generate low voltage, right? We use step up to convert it into high voltage, step up to convert it into high voltage, then we transmit it to the consumer. Then again we use step down ट्रांसफार्मर का हम यूज़ करते हैं बिफोर कंज्यूमर. ओके, सो लो वोल्टेज हम जनरेट करेंगे, उसको हम कन्वर्ट करेंगे हाई वोल्टेज में, देन वी ट्रांसमिट इट, एंड बिफोर it is used by the consumer it will again be converted into low voltage using a step down transformer. And this step down also happen in two steps. First, जो हम ट्रांसफॉर्मर्स देखते हैं हमारे कॉलोनीज के बाहर, those transformers, right, those transformers are step down transformer, जो 2200 वोल्ट्स को या उससे ज़्यादा वोल्ट्स को जो ट्रांसमिट होके आ रहा है उसको कन्वर्ट करते हैं 550 में और थोड़ा कम करते हैं. एंड देन अगेन वी हैव स्टेप डाउन ट्रांसफॉर्मर्स एट आवर होम्स इन instruments like stabilizers or some instruments like that, adapters. इन सब में हमारे पास स्टेप डाउन ट्रांसफार्मर्स होते हैं जो हमारे इंस्ट्रूमेंट के नीड के अकॉर्डिंग वोल्टेज को रिड्यूस करते हैं. लाइक इफ इट इज़ अ मोबाइल चार्जर देन हो सकता है कुछ अलग नीड हो, एंड इफ इट इज़ अ स्टेबलाइजर फॉर रेफ्रिजरेटर देन देर इज़ अ पॉसिबिलिटी दैट द voltage it need is different. So accordingly that step down transformer is designed for that instrument. So this is how the whole process of electrical transmission for long distance work, and transformer, either it is a step up or a step down, play a very important role in the whole phenomena. So that was all about the transformer. Next thing जो हमें पढ़ना है इस चैप्टर में, it is AC generator. So for that, stay tuned, keep studying, be safe. Thank you.